Hello, I am Cem Kaya.
I'm Baha Mert Ersoy.
And I'm Murat Karaca.
Next slide. Uh, Before we start, we would like to show you a short video about our study.
Can I check it first to share something? Okay.
Hello, I am Cem Kaya. I am a graduate from Sabancı University Computer Science and Engineering Department. In this project, we have noticed that people with low vision, it's very hard for them to use virtual reality technologies. Thus, we have developed a digital magnification application for virtual reality platforms using Unity platform to enable them to utilize virtual reality technologies better.
I am Baha Mert Ersoy. I graduated from Sabancı University. I majored in computer science and engineering. The tool we have developed is an accessibility tool in which our goal was to allow people with low vision to navigate through 3D space in virtual environments easily. Our tool consists of mainly two parts: the magnifier, in other words the camera, and the display screen. The users are able to place the display screen and the camera in various locations, giving them many configuration options. As of now, there are a total of 9 configuration options. In addition to this, they are able to change the size of the display screen and the FOV.
I'm Murat Karaca. I'm graduate from Sabancı University in Computer Science and Engineering. To conduct our tests, we developed a test environment that includes 3 categories. One of them is menu navigation, which includes various types of menu navigation, such as game menus and also typing in keyboard. Another test type is collecting objects. We try to build an environment for finding objects. The last type of test is shooting objects. These objects can move, and also testers try to shoot them. We conduct these tests with low vision in various cities such as Istanbul, Ankara, and Eskişehir. We conduct 10 people who are low vision, and we try to fix our bugs via their contribution.
Can you move on to next slide? So, what is MagniVR? From the user's perspective, it's an accessibility tool. It allows the user to zoom in to a particular section using MagniVR. From the developer standpoint, it's a Unity SDK. It's a self-contained Unity SDK. They just have to import it and set up 2 references to apply it. It's very simple to integrate to any Unity project which utilizes OpenXR framework. It consists of 3 main parts. The first being the zoom camera, the second being the zoom display, the third being the control panel. The control panel allows the users to customize a MagniVR tool to their liking. Like my friend mentioned, there are 9 different possible configurations. Can you move on to the next slide, please? So before we started to develop this tool, we had to understand what kind of difficulties did people with low vision have using virtual reality technologies. The first major problem we noticed that they have very hard time navigating through menus. Especially some menus are designed in a way that when the user comes close to that menu disappears or changes shape or moves further away. So this makes that menu unusable for people with low vision. The second major difficulty we noticed they have is them interacting with small or far away objects. Some of our participants also had problems with depth perception and color perception. According to World Health Organization, a significant amount of people have low vision, so these needs should be addressed. Can you move on to next slide? So before we developed this MagniVR tool, we looked at literature, what existed before. There were several custom bespoke virtual reality environments which were created for virtual reality use. There were also other assistive technology tools such as Seeing VR and VRE Assist. Seeing VR was the biggest of them. Our tool extends their magnification lens tool. Can you move on to next slide? You can see here our tool in action. In the picture in the left, you can see the user magnifying a faraway menu. You can see the magnification camera and the display on action here. The picture in the left shows the control panel in which the user can customize the tool. I will leave the stage to Murat.
Okay. For methodology of MagniVR, we had 18 participants in total. We conduct this study in 2 phases. In the first phase, we had 6 participants, and only 3 of them were low vision due to time limitations. Only 3 configurations were available, both camera and display. Also, those configurations could not be changed by users. They were changed manually in the room. We had 9 task rooms and categorized under 3 tasks. The goal of the first phase was a comparison of previous studies magnification tools, especially Seeing VR, and our purposed magnification tool, which were attached to the user's hands in terms of effectiveness, efficiency, and usability. We collected data from time charts and interview, such as you can see from the time chart, which is about completion of all tasks with these 3 configurations. At the second phase, we had 12 participations who have low vision and fully configurable control menu, both display and camera. We already discussed about features of control menu. We reduced task rooms from 9 to 6 since we saw that the completion of whole task took a lot of time and some rooms was repetitive of previous tasks. And therefore, we revised our task rooms, and we will discuss about these task rooms in the future slides. Moreover, we collected data from questionnaires, both pre-test and post-test. Also, we did interview with participants. In the first phase, we also realized that we don't have any instructions for newbies in VR. And also, second phase, magnifier control menu needs to introduce participants before starting actual test. That's why we created a tutorial room which contains visual and voiceover instructions for beginners, such as introduction of VR controller, difference between touch and press action, MagniVR menu, etc. For task rooms, we classified tasks under 3 types, which are navigation, searching objects, and shooting. These are common in VR application and games, and each task are comprising 2 challenges with visual and voice-over instructions. Like you can see in the picture, the instruction says finding correct menu button in the task room. The first type of test is about menu navigation, which simulates VR applications menu navigation and typing keyboard elements. Since most of the time, the menu navigations and keyboards try to maintain fixed distance and small font size, which are challenging in terms of accessibility for people with low vision. In this example, we make fixed distance menu buttons in the task room, which participants are not able to reach there directly. And also, for instance, we wanted them to write erişilebilir sanal gerçeklik in keyboard at the task room. In the second type, we want to create about searching objects that replicates objects interaction in VR applications. The goal of these task rooms is find correct objects and put into the green area. We separated these rooms under organized and unorganized ways. In organized rooms, we put objects in their types, such as you can see in the picture. Heads are in the table. In unorganized room, objects are mixed in the room, which participants need to search all over the room. And the third type of the test is about shooting, which resembling shooting actions in FPS VR games. The participants have dart gun and try to shoot targets in these task rooms. Targets are classified under predicted, that is easy to shoot, and varied, which makes the circular move and hard to shoot.
Effectiveness of the tool was assessed with a pre-test questionnaire and a post-test interview with a questionnaire. Out of 12 of our participants, 10 of them indicated they benefited from the tool. The other 2 participants faced issues with general VR control and a lack of color correction options, which we will further discuss in the following slides. Out of all task groups mentioned in the previous sections, participants have found the tool to be most useful in menu navigation. It should, however, be noted this doesn't mean the tool was found unsuccessful in other task groups. The comparison is merely relative. Next slide, please. As mentioned before, the tool provides a total of 9 different configuration options, and as expected, participants were split in their preferences. One may assume there is a strong correlation between the dominant hand, the display, and camera location, but we were not able to draw meaningful conclusions regarding this. Our results show one simply can't predict a user's preference with such information, further demonstrating the importance of versatility in ER, AR, and VR design. Depth perception should also be taken into account when designing for VR. Some participants had difficulty with head display as they were not able to comfortably interact with the VR environment. Occasionally, they would try to interact with the display itself rather than the virtual world. While an experienced user might not face such issues, VR design should always aim to appeal to beginners as well. Next slide, please. With this in mind, we have summarized the feedback we received from the interviews. To make it clear, these points don't only apply to MagniVR, they hold significance for all VR applications. First of all, menu interaction and control. While designing the menu, we assumed participants would have different preferences when using MagniVR. By that, we mean different display and camera placements, the ability to change the size of the display, and the FOV. And we were right. Each participant had a unique way of using the tools. However, for some of our participants, interaction with the control menu wasn't intuitive, and they also faced issues with depth perception. This goes back to, again, in the previous slide, appealing to beginners. VR design should simplify things as much as possible, especially when it comes to menus. The main reason this project actually came into being was because of inaccessible menu interactions in current VR applications. It should be noted that in accessibility tools such as MagniVR, shortcut design is also rather difficult because this is a Unity SDK that is designed to be used with other applications. This means the shortcuts should be designed in such a way they don't cause conflicts with the main application's shortcuts. All VR accessibility designers should keep this in mind. In MagniVR's case, participants encounter challenges with only a single shortcut, the one used to summon the menu. The shortcut for the menu and the magnification toggle were too similar, and this led to confusion for first-time VR users. They would accidentally summon the menu when they were trying to toggle the magnifier on. The last point is a more specific issue, but a very important one nonetheless. Many individuals with low vision can only see well in very bright environments. Because of this, accessibility tools in more established mediums like PCs usually offer color correction and different contrast options. MagniVR didn't offer any, and some of our participants had difficulty viewing the test environment due to this. Next slide, please. Overall, MagniVR was very effective in aiding low vision individuals. 16 of our participants from both studies indicated it helped them navigate through 3D space in a much more comfortable and natural manner. There were some challenges with controls, but they can be easily resolved in future iterations. Especially in a tool that is designed to be used with other applications, balancing the novice and power users' needs is a must. During the interviews, even before we asked our participants what their thoughts are on possible augmented reality implementations, they all collectively expressed concern over the possibility of lack of accessibility options in such technologies. They also indicated they would like to use an AR counterpart of a tool like MagniVR. Looking at today's VR applications, we can confidently say their concern is very valid. Next slide, please. VR, AR, and other spatial computing technologies will define the future. It is not a question of will it is a question of when and how will it. Today's expensive technologies will be tomorrow's everyday appliances. The current approach to accessible design is not good. It is merely an afterthought as seen in the VR industry. Only by adopting a more inclusive approach to design can we guarantee such technologies can be useful to individuals with impairments. Accessible design is a must. Next slide, please. We would like to thank Professor Kürşat Çağatay for guiding us through this project and granting us the opportunity to work on this project and grow as individuals. We thank Mustafa Yardımcı for providing us a test environment for our tests in Eskişehir. We would also like to extend our thanks to all of our participants who volunteered to be a part of this project and Sabancı University's peer program. Next slide, please. You may now ask your questions, and if you wish to check our tool and perhaps use it in your own projects, you may use the QR code provided in this slide. It will take you to our repo. We would be more than delighted to hear your feedback. Thank you.
Thank you very much. Not only an effective project with cooperation, but also a cooperative presentation. I liked it very much. Thank you very much. Do we have any questions from our participants? Even though I am not in your target group, I would love to use your tool, the MagniVR, because it is very engaging and I'm very enthusiastic. Also, although I'm not in your target participant group, I would love to use it when you come to Eskişehir, okay?
Thank you, of course.